So physics students, good afternoon. In this problem here, we're going to be looking at one of the problems from your homework assignment number 2, which covers over vectors. Specifically, we're going to be looking at what is listed as problem 7 on your homework, which is a two-part problem dealing with a vector that's given both with a magnitude and a direction. As I'll remind you in a lot of these videos, remember, as I work, the values I have are going to differ than the values you have, but the process will be the same. Okay? So I will read my work, my problem, and we will see what we can come up with. It says this: a person walks 15.8 degrees north of east for 1.79 kilometers. Okay? So before I do anything else, I'm just going to stop and I'm going to draw that. Okay? I'm given two values here. And you write my distance, my magnitude, which was 1.79 kilometers. So I'm just going to draw it roughly northeast, my magnitude of 1.79 kilometers. Now, don't let the phrasing of that vector confuse you too much. It says it is 15.8 degrees north of east. That would mean if I was looking directly east, then that would mean that I'm traveling at 15.8 degrees north, so I'm going north of my east direction. Okay? It's just another way of expressing the same information that we've been dealing with. Okay? Now we're told after this information that another person walks due north, then due east to arrive at the same location. How far due north would this person walk, meaning the second person? Okay? So I'm really told some information. I'm told that person 1 walks 1.79 kilometers at this degree, 15.8 degrees north of east. I'm told another person is going to walk, and I will draw this person's path in blue so that we can keep track of it, due north and then due east, only to arrive at the same exact location. So really here I'm told that one person is going to walk at an angle, one person is going to walk due north and due east, and they're going to arrive at the same location. So what I'm really being told here is that one person's walking what we would call the components, the y and the x component, and one person is walking really what would be the resultant vector, or the hypotenuse as we've been dealing with it. Okay? So what we're going to do here is we're really just going to solve for, as it asks in the problem, how far due north does the person walk, and how far east does the person walk. Okay? So I'm going to redraw this a little bit to help us keep track of what we're doing here, so that our angle seems to fit a little bit more. Okay? So here's my person number 1 that's walking the resultant vector, and my person number 2, I'll represent in blue as I mentioned earlier. Now I know that we were told in the problem statement that he walks due north and then due east, and I understand that I'm drawing those vectors in a different way than the problem gives you. But for what the problem is asking us, it doesn't really matter in which order that second person walks those steps, because they're going to arrive at that same final location. So what I'm asked for is how far north would the person walk. I'm going to call that north my y component. Right? It's what we call the vertical direction. I'm going to call for reference that horizontal direction, which we'll be looking at in part 2, the x direction. And here in problem 1, I'm asked to solve for that y component. So let's use what we have. Okay? I'm going to come down here just a little bit. I apologize. Here we go. Okay, so I have my angle, I have my resultant vector, or my hypotenuse. I'm looking now for my y component. So I think back to my acronym for our trig functions, SO, CA, TOA. I have my angle, I'm looking for my opposite side, and I have my hypotenuse. So opposite hypotenuse, that's going to be my sine function. So I'll relate it this way. The sine of my angle, which was 15.8 degrees, is equal to my opposite side, which I don't know, all that y, divided by my hypotenuse, which here's my resultant vector, the 1.79 kilometers. So we've seen expressions that look like this a little bit before. I want to get y by itself. So in order to do that, I'm going to multiply by 1.79 on the right-hand side and by 1.79 on the left-hand side. Remember, that equal sign means what I do to one side, to stay equal, I have to do to the other. So that's going to get rid of that 1.79 value on the right-hand side, and my expression will become something that looks like this. Y is equal to 1.79, remember the units on that are kilometers, times the sine of my angle, which is 15 0.8 degrees. Okay, so if I plug that value into my calculator, 1.79 sine of 15.8, make sure that we are in degree mode, I get about 0.487. Now the units on that are going to be kilometers, because remember the units on my 1.79 were also kilometers. That would be 0.487. We can round to 3 significant figures. Okay? And that would be my y component, how far I'm traveling, effectively north, which is what my problem is asking. And I'll check with my key, 0.487 kilometers. That's what I'm looking for. Remember, that north direction is just another way of talking about my vertical component, my y component, if you will. Okay? So hopefully that will give us a little bit more explanation as to what our problem is asking. Okay? Best of luck.